Okay, welcome everyone. This is the March chapter meeting for CSINext. Hope everyone is having a great day wherever you are. I'm Mark Ogg, chapter president. Today we continue the great lineup of monthly programs we have scheduled for you, and always as a huge thank you to our chapter sponsors, Behr Corporation, Allegion, National Gypsum, and AccuStudio. Your continued support is very valued and very much appreciated. All of our chapter sponsors' web links are available on CSINext website, so be sure to check them out at CSINext.org. Today we have in the house with us Mr. Mike Murphy of Behr Corporation. If at any time, and Mike will be presenting on the value of paint, so if at any time during the presentation you have a question, just raise your hand in the question box there, and we will get to you as soon as we possibly can. So with that, I will turn it over to Mike, let him introduce himself, and we'll get started. So Mike, it's all yours.
Well, thanks, Mark. Good morning, everyone. My name is Mike Murphy. I'm the West Coast Architectural Manager for Behr Paint. I've been a CSI member for, 10, 12 years now, and it's always a pleasure to do these sorts of things. So today we're going to talk about the value of paint. Basically what we're going to do, let me scroll through a couple of slides here, get to the learning objectives. Here we go. Basically we're just going to tear apart a gallon of paint, see what's inside, see what the four basic components of the product is, how they affect quality and performance. We'll look a little bit at latex versus oil-based technologies. And we'll touch somewhat on some of the VOC regulations and some of the governing bodies that control that sort of thing. Although VOC is kind of an old subject anymore these days, we won't spend a whole lot of time on that. Then we'll talk about the characteristics of quality paint and coatings. So let's get started. This is Webster's definition as to what is paint. A fluid suspension of pigment in a liquid, film-forming resin or binder. Those two terms are interchangeable, capable of converting to a solid form when a thin layer is applied to a surface. Of course, the thin layer is key here. We don't want to butter it on too thick because bad things can happen. So what are paints and coatings' main purpose? Obviously, for protection, you don't want what you paint to rust or spall or rot, as the case may be. And of course, main thing I think is beautification. The first thing you see when you walk up to a building or inside of a room, whether consciously or unconsciously, is you see the color. And of course, safety is important as well. Marking off areas that are no-go areas, or fluids or gases moving in pipes, things of that nature. So safety is a big use for paints and coatings. Here's a few painted things and places. Pretty much every architectural firm, firm coatings company is going to have products that will coat all of these different substrates, from swimming pools to certain automotive finishes. Although most companies don't carry the anti-fouling bottom paint on that chip in the upper left-hand corner, you'll have to go somewhere else for that besides your local paint store. So let's get into the basic compositions of paint. You have the solids, you have the solvent, you have the binder, and you have the pigment. Now the binder and pigment tend to make up most of the solids by volume of the product, and it's also solids by weight. So the key thing here you want to look at when you're comparing product data sheets is solids by volume, because that's basically what's left behind after the product is dried. So solids by weight is a good indicator, but you're not real certain as to what the quality of those products are. They may be fillers, they may be extender pigments, etc. So a solids by volume is the key. So if you're looking at a submittal that has a 40% solids by volume product, say, and your product comes across your desk that say is 33% solids by volume, that's enough of a difference to raise some questions about if you're comparing apples to apples. Talk a little bit about the solids here. The resin or binder and a pigment are the primary components that are referred to as the solids. Now, like I mentioned before, we had a few other things in there that may be considered solids, but they're usually a very small percentage of the total solids content. The binder or resin really defines the generic type of product that it is, whether it's a latex, a urethane, an epoxy, an acrylic, etc. And that will also appear on your product data sheets as you're looking at things under the resin type. So you want to make sure that when you're comparing them, that they're the same. So if it's 100% acrylic, you should also, if you get a submittal, it should also say 100% acrylic on the comparative products. The binder provides much of the strength and durability and characteristics for the coating. Urethanes are extremely tough. They're very UV resistant. So the urethane binders and resins provide that sort of features to the product. Binders typically are liquid in the can, but when they're dried and cured, they become a solid film. Okay, a little bit about pigments. Now, obviously, pigments give paint its color, also its body. It helps prolong the life of the paint film just by giving UV protection. It gives it its hiding power. And the two main types of pigments are prime and extender pigments. Here are the two prime pigments that we use primarily. TiO2, titanium dioxide, gives it excellent hiding power and whiteness. We use it in either a powder or a liquid form. TiO2 is a widely used commodity around the world. Your aspirin has it, your paper has it, pretty much everything that has whiteness added has TiO2 in it. It was the pigment that took the place of white lead back in the late 60s, early 70s, when lead was found to be, well, poisonous. So TiO2 was the white pigment that replaced it. Typically, in a gallon of white paint, you'll see anywhere from 3 to 4 pounds of TiO2 in each can. So you can see that the paint industry uses a lot of this material. So anytime there's a glitch in the supply stream, you'll see paint prices fluctuate up and down according to how the wind's blowing with TiO2. Zinc oxide helps control mildew, resists UV light, and resists yellowing. Where I live, up in the Pacific Northwest, we use zinc oxide on our roofs to help control the moss and the mildew and stuff like that. We sprinkle it on the peaks of the roofs and let the rainwater, which we get plenty of, wash it down, and it helps kill the moss and so on. So it has more than one use, just in paint. And also you can put it on your nose to help prevent sunburn. Color pigments. Basically broken down into two types, organic and inorganic. Organic pigments traditionally in ancient times came from plant and animal sources. They produce bright, vibrant colors, although they are more prone to fading because they are organic. Inorganic pigments tend to come from earth sources like yellow iron oxide, brown oxide, lamp black, those sorts of things. Very UV stable, etc. So you can be cautious in specifying colors that have primarily organic pigments for the exterior because they are going to experience some fading, especially in certain parts of the country. Like I said, where I live in Western Washington, we don't get a lot of fade because, well, we just don't get a lot of sun. So things tend to be pretty stable there. But if you go east of the mountains or in the Southwest or pretty much wherever else in the country you go, you want to be cautious in using organic pigments in exterior finishes. Now, say if you simply have to have a bright orange for the exterior of a building, I mentioned earlier urethanes, those will be a good choice to put a bright, vibrant color in because they're very UV stable. They're much more prone to resistance to fade than organic pigments for traditional types of coatings. Even an acrylic latex will show significant fade with organic pigments over not a very long period of time. So you can get the colors you want. You just want to make sure you specify the right kind of product. Here's some examples of modern organic pigments, which basically anything that has a carbon atom in them is considered an organic pigment. There's a group at Oregon State University recently that stumbled upon a brand new UV stable blue pigment that has just been recently approved for commercial use. So things are being created all the time. Some of the ones that we have in our tint machines and most places are quinacridone violet, phthalo blue, Hansa yellow, some of the other very bright, clean types of pigments. So when you, let me go back a second. Going back to TiO2, when you have 3 to 4 pounds of this material in a white base, and you want to tint a color that is, say, a purple or an orange or a blue or even a dark red, we need to take out TiO2 and replace it with these other pigments. So what you experience then is, obviously, with a dark, vibrant color, you're going to have multiple coats to get it to hide and look good. So when we take out the TiO2 and replace it with other colorants to achieve the colors that are required, you give up a lot of the hiding power of the product right out of the gate. So just be aware of that. A lot of times when I'm reviewing a spec for a project, and if the finish schedule is available, I'll ask them to make sure and put in the number of accent colors that they have on the project. That way the painting contractor has a heads up. It isn't surprised when you get the finish schedule and there's a bunch of low hiding colors that are going to require extra amount of labor to complete. So just a good heads up. So nature has been providing pigments for thousands of years. Red ochre, yellow ochre, black, calcite white, which was actually ground up seashells. So if you use these types of pigments and put them in a dark environment, they'll last 30,000 years. So pretty durable. Although the pigments and binders they used was mostly just kind of fats and spit. So it wouldn't really hold up very well on the exterior. Extender pigments. There's a little bit of these in each product. Calcium carbonate or chalk provides abrasion resistance. Talc or magnesium silicate helps reduce sagging, which means the material will stay on the vertical surface and not let go and run down the wall. Aluminum silicate or clay helps reduce settling in the can, so you're not stirring it constantly. Unless, of course, it's a transparent stain, then you do have to keep it stirred up. But clay helps reduce the material falling to the bottom of the can. So we're kind of moving these slides pretty quickly because normally there's lots of questions and we're interaction with an audience. So forgive me if we're going through these a little bit fast. But we'll talk about gloss and sheen levels now. So gloss is measured in 2 different ranges or 2 different angles of observation. One is 60 for flat to gloss ranges. The other is 85 degrees for the more subtle sheens like matte or eggshell and so on. And these standards were established to kind of help standardize things because paint manufacturers like to separate themselves from their competitors by calling their products like suede or leather or pearl or silk or whatever kinds of names they can come up with. But on your data sheets, you'll see the sheen levels. And these are the angles of observation I was talking about. So you can see the 85 degrees will pick up very subtle sheens. 60 degree is more of a universal type measurement. These are the MPI standard gloss and sheen levels from GL1 all the way down to GL6, which is a high gloss. You can see there's quite a range. If you look at gloss level 5 at 35 to 70 units at 60 degrees, there's a huge spread, almost double that would pass typically for a semi-gloss. Most semi-glosses are around the 55, 60 degree range, unit range. You can see that there's overlap on some of these, so it's difficult to have totally standardized sheen levels during the manufacturing process. It just isn't possible from a manufacturing standpoint to have every can, every batch of material come out at exactly 15 units of sheen. So there is a bit of variance there. MPI has built that into their standards, and we in the industry have pretty much adopted all of those. Okay, alkyd resin technology, kind of old school stuff. There are a few benefits still. I don't think very many manufacturers sell a bunch of alkyd products, especially in California because of VOC limits. Even with my company, all of our alkyds are waterborne alkyds, so they are low VOC. But the old traditional alkyds were great. They had superior brushing characteristics. You could open the can up, stir it up, put your brush in, and away you go. You get excellent flow and leveling. Of course, by virtue of non-water-based, they don't promote rust in materials, or excuse me, on metal. And they have excellent adhesion. One of the bad things about alkyd resins or alkyd-based products, as you can see in the picture here, that alkyd resin is sort of an amber color. And in light colors, when you put them on a surface and hide it from light, they tend to yellow off with age. So if you have a inside of a cabinet door or a pocket door and you close it, you can see you have white trim, but you may have a slightly yellowed color on the hidden surfaces. That's typical of alkyd resin or alkyd-based products. It's kind of hard to get away from that. But they do have good brushing characteristics. Although back in the day, in the mid-'80s, when VOC regulations started to come around, we had to take most of the conditioners and solvents that enabled you to stir it up, put your brush in the can, and away you go. We had to take all that kind of stuff out because most of those had high VOC content. So you, as a consumer, when you took the can home, you had to add all that kind of stuff back in to make it work like it used to. So it was kind of a dichotomy where we had to take these sorts of additives and conditioners out, and you as the end user had to put them back in. So it really didn't save a whole lot of VOC content, but we as manufacturers had to take it out by regulation. The government giveth and it taketh away sometimes. Latex resin technology. This is kind of the standard everybody's gone to for the last, 15, 20 years or longer. Our main resins, 100% acrylic, is typically known as the standard of quality around the industry. Vinyl acrylics, polyvinyl acetates, you may recognize those as PVAs, which are commonly used as drywall primers, styrene acrylics, etc. So these are the 5 main resin bases that manufacturers use for their waterborne paints. Vinyl acrylics tend to give a product a little bit more block resistance out of the gate. In other words, 100% acrylics tend to be quite a bit elastic, and sometimes if you're say new construction painting a door jamb and you pull the tape from that, sometimes the 100% acrylic will come right along with the tape and you'll have a jagged edge. Sometimes if you add a little vinyl in there, it makes a better product for trim. It will resist that tape pull just by adding a little bit of vinyl acrylic resin. So if you see on your spec or hollow metal, say for instance, and you specified a semi-gloss 100% acrylic, and then you see a vinyl acrylic submitted as an equal, that may be the reason. Is the person submitting it may realize that sometimes there's some issues with that 100% acrylic in those situations with tape pull, etc. Okay, quality latex benefits include, well, pretty much all these. There's really no reason you shouldn't use a waterborne product name or a latex product. Ease of application, they resist yellowing, very, very flexible. You can even paint rigid fabric with it on the exterior. Good color retention, of course. Water cleanup is the main thing. There's no hazardous solvents to dispose of or deal with. So there's no real reason not to use the latex. Here's some examples of acrylics versus alkyds. Each of these examples were 2 coats of high gloss enamel on bare wood. 1, 2, and 3 are alkyd binders, and number 4 is an all acrylic system. This is only after a couple of years of exposure. So you can see the alkyd systems have suffered terribly, and the acrylic system looks pretty good. Here's another example. This is after about 46 years of exposure. The top left and bottom left are alkyds. The top right is a vinyl acrylic exterior. The bottom right is a 100% acrylic system. So you can see that the 100% acrylic has maintained its color and film integrity for almost half a century. If you use a green color, of course. Just kidding. So quite an example of the differences between those three resin bases. Here's an example of color fade. The samples on the left are acrylics. The ones on the right are alkyds. You can see after about 15 years of exposure how the alkyds have weathered. You can see they don't weather evenly. Sometimes some of these may have some organic pigments in them that have faded out faster. That could be some of the differences in color. But as you can see by contrast, the acrylics perform much, much better. So solvents: water, mineral spirits, alcohol, acetone, lacquer thinner, etc. Water, of course, reduces latex paint. Mineral spirits or paint thinner reduces oil-based or alkyds. Alcohol reduces shellac. Acetone is an industrial solvent used in a lot of different industrial type coatings. Interestingly enough, acetone, by virtue of its low flash point, is not considered a VOC. So that's why it's used for cleaning purposes quite a bit, because it doesn't contribute to VOC in the atmosphere. It dissipates really quickly. Lacquer thinner, of course, thins lacquer. Kind of an old school product. We don't see or sell a whole lot of lacquer out in the field anymore. It's mostly an OEM type situation anymore. So solvents, there's a liquid that dissolves or disperses the solids in the product. It all evaporates during the drying process. Helps improve flowing leveling and keeps the paint's wet edge, which is that leading edge. As you're working, if you let that leading edge dry, you're going to start having lap marks and so on, which is common on large tilt-up projects. You'll see a few striping here and there because it's hard to keep up with that paint drying, especially in certain climates. It's a real circus. So you might see some lapping here and there. Okay, a little bit about VOCs. We mentioned acetone is not a volatile organic compound because it breaks down before it can migrate into the upper atmosphere, where it can cause some real issues. Here are a few of the governing bodies. EPA standards are very, very generous. Nobody had any problem making materials to conform to those. OTC started up in the Northeast, has since spread to a few other states, I believe. But the South Coast Air Quality Management District is the standard by which we manufacture, because we make our materials in California. And most LEED standards, Green Seal, etc., conform to South Coast standards. The nation of Canada subscribes to them. So it's here to stay, and that's the agency that kind of drives the bus on VOC content. Benefits of green paints: well, of course, very low odor, zero VOC, zero HAPs or hazardous air pollutants. They have antimicrobial properties. They were designed for LEED projects and LEED V3, V2. They've been adopted for many different school protocols. The materials are excellent. The first generation low VOC products were terrible. The professional painters hated using them. They didn't cover. There was poor touch-up. There were lots of different issues, but that was about 15, 20 years ago. Now, everybody manufactures to basically LEED V3 standards for interior paints, and the performance is outstanding. So there's no reason not to specify low or zero VOC products. Additives. We also throw a little bit of this stuff in there for various reasons. Biocides help prevent bacteria and fungus growth. I don't know if anybody's ever smelled a can of spoiled latex paint, but it's pretty bad. So biocides are used to help prevent that when it's being stored. Rheological agents control the viscosity. Surfactants, interesting product. We use a lot of surfactant. Basically, it's a wetting agent that helps encapsulate and disperse pigment in the products, and it's widely used for various other types of products. In fact, here during the Deepwater Horizon oil spill, millions of gallons of surfactant were sprayed on the Gulf of Mexico to help disperse the oil that was on the surface. Dawn dishwashing liquid has lots of surfactants in it. That's why they use it so much for cleaning birds and animals that get soaked with oil. So, and we use lots of it in paint. So when that whole disaster occurred, there was a shortage of surfactant, and it was difficult to get some to manufacture materials. So it's an interesting product. It sometimes in certain climate conditions and temperature conditions, the surfactant in paint will migrate to the surface all at once instead of gradually curing, and that's what we call surfactant leaching or surfactant bleed. It's kind of unsightly. A lot of times it's apparent in darker colors because the liquid pigments have certain surfactants in them. So when you combine those with paints that are what do I say, dark, I guess dark colors is the simplest way to say it, you can get some surfactant bleed, because adding that much colorant does extend the drying time of the product out, sometimes double. So if you've got a light beige versus a dark accent blue, say for instance, that blue is going to take at least twice as long typically for it to dry, depending on conditions. So if the dew point rises and humidity rises, you may see some surfactant bleed along the drip edges of, say, hardy or metal. Sometimes it's apparent over whole panels or whole surfaces. It's unfortunate, but it does wash off pretty well, and in most cases it doesn't really affect the performance of the coating. It just, instead of curing gradually, it just comes to the surface all at once. Defoamers or bubble breakers help eliminate foaming when you're rolling the product on. Your roller shouldn't leave a streak of bubbles behind when you're applying the product. Dryers help control the drying time of the paint. Anti-skinning helps keep paint from forming a skin, etc. So lots of different types of additives. These are just a few, and they all have a distinct purpose. Well, this is the "it's wet until it dries" slide. This is how a paint film cures. And that green square is important, especially where I live. Application conditions are critical when applying latex paints. So it needs to have low enough humidity to draw the water out of the product and help it start to cure. So be careful when you're applying it if you're a homeowner and you're out. If you're like me and you're painting in the first week of October because you goofed around all summer and now you've got to put material on and your paint windows from about 10 o'clock to 2 o'clock in the afternoon, and it's already 5 o'clock and you're sweating it, and then the next morning you come out and your landscaping is the same color as your house. Well, you waited too long. You didn't use it under ideal conditions. Okay, quality characteristics. High again coverage. The sample on the left looks pretty darn good. The one on the right, not so much. So if we were going to improve that product on the right, the first thing you would do is probably add a quarter to a half pound of TiO2, bump the price up a couple of bucks a gallon, and you'd have a good product. Now, keep in mind there are markets for this type of product on the right, primarily new home construction, where they are painting that surface 3 or 4 times before it's finally occupied. So that there is a market for those lower hiding type products, but most good commercial grade products that you'll see submitted are going to have characteristics like the one on the left, because you'll get better hide with fewer coats. Block resistance. I mentioned block resistance earlier with 100% acrylics. Pulling away, this is a weight placed on a 3 mil dry paint film over a period of time, and it should look like the example on the top, not the ones on the bottom, where typically on horizontal surfaces it's hard to put on the material at the precise millage or wet mill thickness, and you tend to kind of stack it on there, and then it just takes longer to cure. If you recoat too soon, you can trap some solvents and you can have poor block resistance, or you can get wrinkling and things like that. So proper cure time, proper wet and dry millage is important to help have good blocking characteristics. Adhesion. This is a simple ASTM test. You score the surface with a blade. You get a roll of ASTM D3359 approved tape, not from the beginning of the roll or the end of the roll, but somewhere in the middle. Put it on the surface and give it a pull, and see how your adhesion is through several layers of paint. Now, one of the things about this test, especially with renovation projects, is you can expose lead. So you kind of got to be cautious. Look at the age of the project and see if it was coated prior to about 1968-ish or so in there. Chances are there could be lead lurking underneath the surface. So this is a good thing for testing for passivators on galvanized metal. If you're recoating and you want to make sure that the previous coat of material has adhered to the galvanized ductwork, say, for instance, do the simple test out of the way and make sure that the paint is sticking before you reapply and cause some issues with a second coat over a poorly adhered surface. Scrub resistance. This is a scrub meter. Each back and forth motion is counted as one cycle. And on the right, you can see the paint sample has suffered terribly. The one on the left looks like it's still in pretty good shape. Now, some measurements go with deterioration of sheen as a scrub test. Others goes to the failure of the surface itself. So you kind of need to determine which one you prefer. I think in subtler sheens like eggshell and so on, loss of sheen is not as much of an issue as it would be, say, with a high gloss. We're looking more at the destruction of the paint film during a scrub test than just basic loss of sheen. Touch-up. Well, everybody has had touch-up issues. And the one on the left is no different. The one on the right is a much better touch-up. Basically, the best way to do touch-up is to go corner to corner. And there are lots of different factors that influence touch-up. One is the recycled drywall paper. It's very, very porous. Sometimes the prime coat is not sufficient to wet that surface down. So when the finish coats are applied, they absorb into it. And when touch-up comes along, then you're building millage and you're building sheen and so on, and you have a very difficult time doing it. Temperature affects touch-up. So say if the project is painted in February and touched up in May, there are physical changes due to temperature in materials that can cause some touch-up issues. Spray versus roll. When you atomize paint through a 17 thousandths orifice tip under 2,500 pounds of pressure, you physically change the characteristics of the paint. So when you're spraying it and you touch up with a brush or roller later, you can see a definite difference. That's why lots of commercial painters will atomize 5 or 10 gallons of paint through their airless paint sprayers just for touch-up down the road. That does seem to help. Colors. Back in the glory days of the paint business, when there was 6 or 8 ready mixed off-white colors to choose from, and that's what was typically used, there was very few touch-up issues going on. Now in the last 10 or 12 years, no, probably longer than that, designers have gone towards more saturated type colors in the beiges and taupes and things like that. Sometimes those are very difficult to touch up as well. So industry-wide, on commercial projects, typically touch-up is going to corner. That way there's no issues. Quality paints tend to have more touch-up problems than value-engineered products. New home construction products, dead flat, etc., very chalky appearance, pretty easy to touch up. Higher quality products used on commercial jobs are more difficult because they will tend to build sheen, especially when you look at them at, say, a 60-degree angle of observation. You can tell that there is a little bit of sheen difference. And a lot of times that will go away. Typically, a latex paint film takes about 45 days to cure completely. A lot of that has to do because they're water-based products, and sometimes it takes longer for that water to evaporate out. Whereas solvent-based products, they're cured in 7 to 10 days because the solvents evaporate. There's no water to contend with and no humidity issues that can slow it down. Okay, a little bit about coating systems. Trying to see how much time we have here. Yes, we're okay. So selecting a product, I put
20 minutes left, Mike.
20 minutes left?
Yeah, we got usually it looks like we've got probably about 6 or 7 questions here at the bank too, so.
Oh, do we? Okay. I'm trying to see.
Mike, I accidentally muted you there. I'm sorry.
Yeah, I saw it going back and forth there. I was muted and I was not muted. Okay, so this won't take much longer than we can get to the question. So selecting your product, I put 3 examples down here: wood, concrete, steel. The first factor of selecting a product is consideration of the substrate. We're going to talk about primers here first for a few seconds. So primers help promote a uniform application of the finished coating, which results in a better final appearance. So basically, primers have several different functions. They adhere to the substrate. They provide a homogeneous surface to paint. There's no uneven or different porosities going on, say if you're spot priming and so on like that. So primers are really important. Everybody has that in their specs. I know that my company is a big proponent of a paint and primer one type system. That's an excellent marketing campaign, but for typically commercial projects and so on, we like to see a primer being used regardless. Now you can use those fine products as top coats. We have no problem with that, but I like to see you use a primer, period. So concrete, elastomerics are recommended if crack bridging is a concern. High pH tolerance, if it's fresh concrete, you want to use an alkali resistant primer, just so you get good adhesion without the alkali burning through the finish coat. CMU, same way. Block fillers are standard primers for CMU, just to fill the pinholes so you get a good water repellent or waterproof surface. Elastomerics work well on CMU if crack bridging is a concern. Acrylics are always kind of the standard for the finish coat. Wood, you may have some tannin bleed, so use a primer that helps block tannin from migrating to the surface. Most of these wood primers are now acrylics, or 100% acrylics. So people say, well, isn't tannin a waterborne stain? Well, yes, it is, but these products are made to lock that stain into the paint film and not let it migrate through the finish coat. Metals, lots of different types of primers for metals. In this case, we're just going to mention DTM or direct to metal coatings, which can be applied direct to a clean metal surface that may have a very minimal amount of rust or flash rusting. DTM coatings are here to stay. They're pretty darn good as the first level of protection. I think, of course, with metals, you can go anywhere from a DTM up to an epoxy to a urethane to a siloxane. So there's various levels of protection you can specify according to budget and project requirements. This can certainly be a factor. So selecting a finish coat product. First, use a family of coatings based on the substrate. We mentioned elastomerics, acrylics for flexibility and color retention, urethanes for corrosion protection, epoxies for scrub and chemical resistance on the interior. So then you fine-tune the selection based on these 3 things: project requirements, your budget, and your maintenance cycles. So when I do a spec or a spec review for a certain project, I'll ask questions. Okay, who's going to maintain it? Is it going to be a professional facilities supervisor, or is it going to be a casual type guy who's also the plumber and the carpenter and the drywall guy? What's your budget? Are you building this to sell right away, or is this going to be a facility you're going to own and manage over time? What are the project requirements? Do you need a zero VOC system throughout, or can you use a higher VOC, better performing product on certain substrates that will give you better maintenance cycles? So lots of different things factor into to selecting a finished system. Many of you are probably familiar with the MPI system. They are more of a generic type thing. They've attempted to standardize lots of substrates with different paint systems, and it's a good start. It's a good framework, but I think in talking with your coatings representative, I think you can dial in your specs a little bit better to be more project specific and have better performance out of your paint system, which makes your clients happier and get you more work. So that's the end. Now, you said there were some questions, Mark?
Yep, we've got a few sitting here, and thank you very much for that. Let me bring them up here. The first one we've got is what type of advice, recommendations do you have for trying to explain the technical aspects of paints to your client base? So I know we talked about the solvents and the pigments and the binders and all that stuff. What advice do you have for trying to explain some of the subtle differences between applications and the contents of the paint, why it performs the way it does in layman's terms? Because I know as contractors, architects, engineers, we all understand that because we deal with it every day, but somebody like a client, that's not real versed in construction and architecture, et cetera, it'd probably be a lot of information overload.
Well, yeah, I'm sure it would be. I guess if it's a DIY or someone like that, well, that's kind of a good question, because there's various ways you can go to a paint store. You can ask the questions for your specific project. If you want to paint the outside of your house, say for instance, and you don't know what to use, there are various levels of quality. You can buy paint that's $50 a gallon. You can get it that's $40 a gallon or $30 a gallon. So actually, price does have an impact on the quality of material.
Get what you pay
most
for.
Companies, right? You get what you pay for. And most companies will have a one-coat product with a lifetime guarantee. Now, lifetime guarantees to me it's a gimmick, but it does establish a level of quality too. You're going to pay more for it. The value engineered products are going to be cheaper. You're going to be unhappy with them. They're going to have different application limitations or issues. For instance, a cheap product is not going to roll very well. They're made primarily to spray. So if you're buying a $12 gallon of paint and you're going to expect it to roll out and have excellent hide, well, you're going to be putting a lot of coats on to get that excellent hide, and you'll be spending the same amount of money you would have spent on a better grade product. I hope that answers the question.
Next one here on the. Okay, I understand what it's asking. On the zinc oxide application there that you were talking about with your roof up in the Northwest there about the moss and all that, are there any implications, or have there been any issues, or does it in any way, does that type of application, if you're in a project that is going for a LEED type certification or a green type certification, is there any type of implications or issues using that on a roof where you're using that rainwater for non-potable uses?
Yeah, I would not do it.
Okay.
Yeah.
And when you'll
see, excuse me, Mark, you'll see sometimes, like where I live, there'll be some of the roofers will apply zinc strips underneath the shingles on the peaks of the roofs. I have it on my home. Now, whether or not that would cause issues with rainwater collecting with the metallic zinc that you'll see, I don't have an answer for that, but I would be cautious in doing that.
Application. Okay.
The sprinkling of the zinc oxide powder on roofs is more of a homeowner maintenance type thing than because it only lasts for till the rain comes along, and so it's more of a springtime thing up where I live. It's not a standard procedure for maintaining things.
And when when an application like that gets specified, is there anything that needs to be particularly noted in the spec itself, or?
I don't know.
Okay.
I've never seen a spec with, specifying a zinc oxide on the peak of a roof to help prevent moss and mildew growth. That's I think that's something that would be consult with the roofer about,
okay,
to see what they recommend.
More of a roofing question than a paint question.
Yeah.
Okay. As far as workers from contractors and such being able to be trained, proper applications, let's take like an open shop environment. What are different ways that contractors can use someone like Behr to better their workforce? Are there training programs or applications or seminars, et cetera, that can be attended or watched or applied, so contractors can better train their workers in field applications?
Yeah, there sure are. Most major cities have a local PDCA chapter, Painting and Decorating Contractors America chapter, and many large cities have painters unions. They provide training for their people, both in application and in cleanup and care of being good stewards of what they're doing. They're not rinsing paint down the storm drain and things of that nature. We're pouring solvent out in the backyard because nobody can see it. But there's lots of different ways. Some community colleges even have painter programs where they can learn proper application, especially with industrial coatings. They go through rigorous training for applying things at the proper millage. Okay, so every architect firm should have a wet mill gauge in their desk drawer. That way, when they go out on the job site, they can check for proper millage application, because every product data sheet has that information on that recommended wet mill thickness. And wet mill testing is a non-destructive test where you can just stick the wet mill gauge against the surface and make sure it's being applied correctly. Especially important when doing things like elastomeric coatings where there's a warranty involved. You want to have that material applied at the correct warranty or correct millage to achieve that warranty. So a wet mill gauge is a really handy little tool that looks like a credit card with notches on the edges, and away you go. And plus, heck, the painters will stand up straighter, and they'll maybe put a brand new tip in their machine and dress nicer on the project. If you show up there with your mill gauge, you get a little bit of respect out of them. So,
question on the touch-up with your corner to corner. Is that something that is just considered an industry best practice, or is that something that is just is that something that needs to be, I don't know if that needs to actually be specified or noted, or is that just something that the contractor is responsible for as part of their needs and methods?
Yeah, that's.
I've never heard of the corner to corner, and maybe my contractors have done it.
Well, it's a not a, well, you can put it in your spec, but sometimes you may not need touch up. But typical standard is with the darker colors and so on, because of the issues that are involved in the callbacks and the punch list and this sort of thing. Most commercial painters will find it easier just to go corner to corner with touch up. Now, industry standard is 3 feet perpendicular to the surface. If you can't see it from that angle, then it's considered successful touch-up. But if you go to a 85-degree angle of observation and put a bright light source at the end of the hallway, and you can see where there's some touch-up marks, well, is that fair or not? But if it's 3 feet from the surface and you can't see it under normal light conditions, then it's considered successful touch-up.
Okay. Is there, have you experienced anything, or what type of moisture testing is required in an environment before you actually start to apply the paint. And I think that question's probably coming from, say a project that's not totally boxed in yet with windows and doors, but they're going to go ahead and start priming some of the interior walls that are already up and dry, sheetrocked and finished out, ready to go for primer. Is there any type of moisture tests that are required or recommended to make sure that there's not excess moisture in the walls or in the area, or say even like there's another question down here that kind of ties into this one for like applications with concrete floors, moisture requirements, moisture testing methods, recommendations.
Oh, yeah, definitely. Of course, there's a moisture meter, which is a little two-pronged device you insert into wood, say to get a moisture reading from wood. Some you can do into drywall. It's not really common because usually by the time it's ready for the drywall to be painted, things are dried in. They got some sort of heat source, so usually moisture conditions on the interior envelope aren't that big of a deal. For concrete floors, super critical that the moisture issues are addressed. Now, always there should be a vapor barrier under the slab. One easy test for moisture on concrete is to get a piece of like 4mm visqueen, say a 2-foot square, tape it down to the concrete with duct tape, and then come back the next day and see if there's any condensation on that visqueen. If there is, then there's moisture issues. So that either has to be you wait until the concrete is cured further, or you try to find the source of the moisture, or use a product that resists hydrostatic pressure through that floor, and you cross your fingers and hope things work out, because it can be a real issue.
Same person that asked me just pinged me with something else. Is in like a concrete floor application that's maybe just getting some type of paint application on it. Do you guys work with do you recommend working with the concrete spec to either specify or not specify a sealer on that concrete when it's first placed? Because I know my experience with most floor coatings is whatever sealer's on that floor is going to get scuffed up and taken off before they put whatever coating they're going to put down on it to begin with, whether it's epoxy, whether it's paint, just so they can make sure that it bonds and adheres.
Yeah, you're right. Most specs, concrete specs, call for a hardener or a dust proofer of some sort. And yes, that depending on the kind of coating system you use on that floor, that has to come off before the coating system's applied. So it's there, but when you paint over it, you're going to wheelabrate it or shot blast it or water jet it or some method of removing that to get to a bare profiled concrete surface. By profile, I mean when you're done prepping it, it should have the feel of about 60 grit sandpaper. That will give it a good bite for the prime coat to adhere to and soak into the concrete, and then you build your top coat system over that. Okay.
All right. I think that wraps us up. Got through all the questions. Great presentation, Mike. Great information.
So thank you.
Taking the time out of your day out on the West Coast there or morning, I should say, to talk to us. And again, thank you for Behr being a sponsor of the chapter, and appreciate your time.
It's my pleasure. Thanks, you guys. And
thanks, everyone. See you next month.
Well, y'all take care. Uh-huh.